All right, good day. Today we're going to be doing physical science for grade 11 together once more. Let's start. I'm Musala Liburu. You can always get me on Twitter is @MusalaDL and on Instagram is post_silicon. Right, we're going to be looking at the homework that we had yesterday, and then I'll be providing feedback of that homework. Right. The question was an induction coil of an area of 48,6 cubic centimeter and 200 windings is rotated clockwise in a constant magnetic field of magnitude of 2,4 Tesla. Refer to the diagram below. The graph below shows the induced EMF varies with the inverse of time. First question is state Faraday's law in weights. Question 2, use the information in the graph to calculate the change in the magnetic flux. 3, the coil rotates through an angle theta to a position where the magnetic flux becomes 0. Calculate the angle theta. Right, let's start with question 1. Question 1, we are asked to state Faraday's law in weights. So stating Faraday's law in weights, it says the magnitude of the induced EMF across the ends of a conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. Right, and then question 2 was use the information in the graph to calculate the change in the magnetic flux. So what is that we know? We looked at the graph, and then if you look at the graph on the side of EMF, this is the EMF. You can see that this is 1, 1.2, 1.4, 1.6, 1.8, and then 2 volts. Now, the blue line is indicating that this is 1.6, EMF is 1.6, and then equals to number of windings, N is 200 windings, so it's 200, and then we are looking for magnetic flux linkage. So in calculating that the magnetic flux, I conveniently selected time equals to 1. Why did I do that? Because 1 over 1 is 1, so that I can substitute this to be 1. So 1 over 1 is 1. So here, what is that? We know EMF is 1.6. And then time, it's 1 over 1, which is 1. And then number of windings is 200. And then we are the only unknown that we are having here is the magnetic flux. Then if you cross multiply, if you solve here, you would then multiply every side by 1 and then divide by 200. You should be getting 0.008, which is and magnetic flux is measured in Weber. So it is 8 times 10 to the power minus 3. 8 times 10 to the power minus 3 Weber. So which is the same as this comma is moving 1, 2, 3. And then because it was moving from the left, we say minus 3. So that's the value of the magnetic flux. Right, the next question is, the coil rotates through an angle theta to a position where the magnetic flux becomes 0. Right. So what is that that we know? We know that a magnetic flux equals to EA. So cos theta. So we know that the change in the magnetic flux will be equals to final magnetic flux minus initial magnetic flux. And then in terms of this, it will be given by BA cos theta final minus BA cos theta initial. Now, we know that this one here, it is the same as 4.86 times 10 to the minus 3. Let's see where do we get it. So remember that if you are having centimeters and you want to convert the centimeters into meters, what is that that you do? You divide by 100. Né? And then in this instance, you are not only dividing by 100, you are dividing by 100 square because it's square centimeters. You want to convert it to square meters. So it will be 100 squared, which is 10,000. So it means you are dividing 48,6 divided by 10,000, which is, it is 0,00486, which is the same as 4,86 times 10 to the power minus 3. So that will be how to do it, because one might be asking, you are having 48,6 centimeters square. Why are we writing 4,86 times 10 to the power minus 3? So the reason for that is simply because you are having this one, you are to convert from meters, from centimeters to meters, you divide by 100, but this is centimeters squared, so it means it's 100 squared, which is 10,000. So 48,6 divided by 10,000 will be 4,86 times 10 to the power minus 3. Right. That is the initial magnetic, the area there. And then the magnetic field is the same, is still 2,4. So I'm sorry for substituting this interchangeably, but like it is BA, is because it's the product, it will give you the same answer. Right. So now, when do we have when does cos theta become 0? It is when you are having cos of 90, right? And then minus, right? Remember, cos of 90 is 0. So you are only getting the magnetic flux becomes 0 only when you are having cos of 90. So now minus, this is the same area, and then this is the same, 2.4 is the same magnetic field, B. And then cos theta, we do not know the angle theta. That is responsible for this. So we are looking for that angle. So now theta will then be equals to cos inverse of all of this is 0. This part here is 0. And then you are dividing 0.008 by this product here. You will be getting 0.86. So theta will be the cos inverse of 0.86, which is theta will be 46,7. So theta, angle theta will be 46,7. Right. So let's carry on. So today we are looking at the types of reactions. So we will be paying specific attention to the acid-base reaction. All right, at the end of this lesson, you should be able to know the different types of chemical reaction, the acid-base reaction as well as redox reaction. Understand the acid-base reaction. Under the acid-base reaction, you should be able to define acids and bases according to Arrhenius theory and Lorentz-Bronsted theory. And then identify the conjugate acid-base pairs for the given compounds. And then you must be able to describe an amphiprotic or an ampholyte. You should be able to write the names and formula of common acid like HCl, HNO3, and then H2SO4, and then CH3, COOH. That is hydrochloric acid, nitric acid, sulfuric acid, and acetic acid or ethanoic acid. Right, you should also be able to write the names and formulae of common bases. That is, for instance, ammonia, sodium carbonate, which is also called washing soda, and sodium hydrogen carbonate, and then sodium hydroxide and potassium hydroxide. And you should be able to write the reaction equation for the dissolution of acid and bases in water. And finally, you must write the overall equation for the reaction of acid with metals, metal oxide, and metal carbonate. Right, you must also be able to describe an acid-base indicator. You must identify the acid and the base needed to prepare a given salt and write the equations for those reactions. You must be able to write down neutralization reaction for common laboratory acids and bases. Right, let's look at the common names of acids and bases that you'll always encounter. Right, hydrochloric acid will be given as HCl, sulfuric acid as H2SO4, and then nitric acid HNO3. Ethanoic acid will be, which is also called acetic acid, which is a component of vinegar. It's forming 6% of vinegar. And then it is H3COOH. And then ammonia, it's a base. This is the formula for ammonia. Sodium carbonate, which is this one. And then sodium hydroxide is NaOH. And then sodium hydrogen carbonate is NaHCO3. And then potassium hydroxide. These are common acids and bases. So you may have a snapshot of this so that you are able to remember them. Right, let's look at Arrhenius theory. How does Arrhenius define an acid and a base? Arrhenius is saying an acid is a substance that produces hydrogen ions or H+. This should be a superscript. H+ hydronium ion when it dissolves in water. So anything that will dissolve in water and produce hydrogen ions or protons, it will be an acid. Right, let's look in here. All right, this is the reaction of two acids. So, all right. Let's just look at this one in yellow. It is hydrogen, sorry, it is hydrochloric acid, and then it is combining with water, it produces oxonium ion, it produces, it donates H plus, it produces H plus or hydronium ion. So it is water with additional hydrogen, which is this one. And then, of course, you'll have the chlorine in the solvated in water. So this is just the reaction. This is typical of neutralization reaction. But if you look at this particular one carefully, you can see that the sulfuric acid has donated the H plus to this particular to the OH to form water. It has donated this to H. But this is not Arrhenius theory, it is the Lorentz-Bronsted theory. This one in white, it is representing the Lorentz-Bronsted theory. The first one here, it is just representing the Arrhenius theory. Right. A base, according to the Arrhenius theory, is a substance that produces hydroxide ions, OH, when it dissolves in water. Right, for instance, ammonia here dissolves in water to produce OH. So it forms ammonium ion. This is ammonia, it produces ammonium ions and OH. So this OH is an hydroxide. So it shows that it is a base. So Arrhenius theory says a base is a substance that produces hydroxide ions when it dissolves in water. Right, the one below here, it is just to represent the Lorentz-Bronsted theory. Right, and then Lorentz-Bronsted theory say an acid is a proton donor. So if you look at this two that is written in white, you are having a nitric acid here. What is that it does? It donates a proton to the OH to form water, right? And then, sorry, it donates an H plus, that is a proton, to form water. So the OH plus the H donated by the acid forms water. So an acid is a proton donor. Right, same applies to this case here. You can see that sulfuric acid has donated a proton to this water. So it is a proton donor, right? And then the same applies here. You are having sulfuric acid donating the two protons to sodium hydroxide to form to the hydroxide ions of sodium hydroxide to form water. Right, so a base is a proton or an H plus ion acceptor. So you can see always here, if you are having HCl reacting with sodium hydroxide, which is a base, the base, the hydroxide accept the proton from the acid. So it's a proton acceptor. So it has accepted a proton from the acid to form water. Right. The Arrhenius theory says an acid is a substance that produces hydroxyl or hydronium ions when it dissolves in water. And then we have given the example there. And then a base is a substance that produces a hydroxyl ion. So a hydroxide ion when it dissolves in water. So basically that's what we have there. Let's look at conjugate acid-base pair. So we are saying that an acid HA loses a proton and then its conjugate base will be A, which will be formed. So whenever this acid HA loses a proton, its conjugate base A minus will be formed, right? When a base A minus accept a proton, its conjugate acid HA is being formed. So these are said to be called conjugate acid-base pair. Let's look at the example here. You are having ammonia, which is a base, and then what will be its conjugate acid pair? Its conjugate acid will be ammonium with its NH4 plus. So it means ammonia has accepted, and when it accepts a proton, it forms its conjugate acid. Now let's look at water. Water here is acting as an acid. It is an acid, it loses a proton, it forms an OH minus, which is a base. And so this is acting as an acid here. Right. Now I'm going to explain that water is called an ampholyte. Why is it called an ampholyte? Because in some of the reaction, it is acting as a base, and in some of the reaction is acting as a acid. So ampholyte is a substance that can act as both an acid and as a base. Right, let's look at this, the following one here. You are having this one, which is acting as a base. And this one is acting as this hydronium ion is acting as an acid. Why is it said to be an acid? Because it is donating a proton to form a base. So here water is a base. Now, in here, in the this one here, the ion here is acting as a base. Why? Because it is accepting a proton from the oxonium ion or the hydronium ion to form the phosphoric acid. Right. So it is accepting this to form this acid here. Right. And then in the reverse reaction, this is it's an acid. In the reverse reaction, going to the left, it will donate its hydrogen to the base, which is water in this instance, to form hydronium ion. And then that is what is happening. And then now it will end up having this base here. Right, let's look at hydrochloric acid and water. We are saying water here is acting as a base. So water is acting as a base because it is accepting a proton to form the acid on the right-hand side, which is the hydronium or oxonium ion. So here, the water here, it is a base, and then its acid, conjugate acid will be oxonium ion. Then this one is an acid, and then its conjugate base will be the chloride ion. Right, like I've already explained, amphiprotic substance is a substance that can act either as a base or as an acid. It can either act as a base or acid. It is also called an ampholyte. So water is a good example of an ampholyte. So in this reaction here, it is acting as a base because it is accepting a proton. And in this one, it is acting as an acid because it is donating a proton to a ammonia to form ammonium ion. Right. Now, reaction equation for dissolution of acid and bases in wood. So if we're having this acid, nitric acid, dissolving in water, you are going to have, sorry, this should be, I think, this one here should be oxonium ion. So this 2 is not there. So it should be oxonium ion and nitric acid. Right. Sorry, this should be oxonium ion. This is how the oxonium ion look like. It should be a H3O and then plus. This is not a 2, this is supposed to be a 3. H3, this is the oxonium ion, right? Should be written here. And then here you are having sodium hydroxide plus water will give you what? Will give you sodium solvated and then also hydroxide ions also solvated. Right, we have talked about this water, this slide. Let's consider this one here. What is an acid-base indicator? An acid-base indicator is a weak acid or a weak base, which color changes as a hydrogen ion concentration or hydroxyl concentration in the solution changes. Right, what is an acid-base indicator? It's a weak acid or a weak base of which its color changes as hydrogen ions concentration or hydroxide ion concentration in a solution changes. So these are the examples of the commonly used indicators. You've got litmus indicator. Normally it is a piece of paper. So in an acid, this is the color changes. And then in basic solution, this is how it will look like. So you also have methyl orange, which will have these color changes. And you also have bromophil blue, which have this color change range. And then also phenolphthalein. And then next time, I think I'll look for universal indicator just to show you the color changes and the specific pHs. So in a pH of about, in a basic pH, the methyl orange will be more yellowish, and then it will be more reddish when you are having a acidic condition. And in a neutral media, it will be more orange, right? Okay, we are having the first question there. NH3 ammonia dissolving in water to give you ammonium. This is ammonia, which is normally a gas. And when it's dissolved in water, it will give you ammonium plus hydroxyl ion. And then you have to explain why hydroxyl ion is regarded as a Lorentz base. Why hydroxide ion is regarded as a Lorentz base. So the reason for that is that in case of the reverse reaction, if this reaction is being reversed, it will act as it will accept the proton. So in case of the reverse reaction, it will accept the proton. So in case of the reverse reaction, it will accept the proton. So it does not, this one, it is not Bronsted theory, but it is Arrhenius theory. So it does not release this hydroxyl. It's not because it is releasing the hydroxyl ions. It is because in the reverse reaction, it can accept the protons, right? And then identify the type of bond responsible for the formation of ammonium ion in the above equation. So it is dative for coordinate bond. And then write the balance chemical equation to show how ampholyte in the above equation will react with a base and will act as a base when it reacts with hydrochloric acid. So an ampholyte here, it is water. Remember, we have said that water is an example of an ampholyte. So now to show how it will act as a base when it reacts with hydrochloric acid, it is how we go about it. So it will dissolve, hydrochloric acid will dissolve in it. So sorry, this one, it should be, sorry, this one should be an hydronium ion. There's no 2 here. So it's just an O. So plus chloride ions. So this is the equation without this O. Because you can see on the left-hand side, it's only 1 O. So this O is not there, but the positive charge is there. Right. The next question was define the term concentration. Concentration is the number of moles of a solid per cubic centimeter, per cubic densimeter of a solution. It is the number of moles per cubic densimeter of a solution. Right. Then you have been told that 5 cubic decimeter of nitric acid with a concentration of 0.75 mole per cubic centimeter is spilled accidentally on a small pond of water. Right. The acid and the water has a total volume of 1,000 cubic centimeters. To neutralize the acid, calcium hydroxide is added to the water. Right. Now, here, what is that we needed to do was to calculate the concentration of the acid after it was spilled in the pond. So in here, let's just quickly correct something. Now we want to know the concentration of the acid. So we have defined the concentration of the acid after it is spilled in the water. So we know that concentration, the initial concentration was 0.75. Equals to number of moles over volume. So the number of moles of the acid was 3.75 mole of nitric acid, right? So now, what will be the new concentration? The new concentration will be a number of moles divided by volume. So the volume here should not be 1,005, should be just be 1,000. So it should the new concentration should then read just a moment. Right, the new concentration then should read, this should be 1,000. And then in here, it should be 0,00375. And then also in here, it should be 375 times 10 to the power minus 3. So that should be the concentration. So, right. So because we have been told that the total acid and water the acid and water is the total volume of 1,000 cubic decimeters, right? So now we have been told to use calculation to determine if 120 grams of calcium hydroxide will be sufficient to react completely with all the acid. So will this base neutralize the acid in the pond? So we know the number of moles of the acid, which is N equals to 3,75 mole of the acid. So now we want to check the number of moles of a base. So number of moles equals to what? Mass over molar mass. So what is the mass in grams? The mass in grams of calcium hydroxide, it is 120, and the molar mass of calcium hydroxide, it is 74,1. So if you divide 74,1 by, so if you divide 120 by 74,1, you should be, now something is going wrong here. It is calcium hydroxide. Let's just check if everything is correct for this one. Calcium should be having the, let's go to our periodic table. Calcium is having molecular mass of 40, and then oxygen is having 16, plus hydrogen is 17. So it is 40 plus 17 times 2, which should be 74,1 is correct. And then 120 divided by 74,1 should give you, this should be, let's just escape a bit and then do it again. This should then be the number of moles here should then be 1,62, which is the number of moles that will be there. So this should be 1,62. So now we want to know if this will be able to neutralize the acid there. So we have calculated the number of moles of a base, which is calcium hydroxide. It is 1,62 mole. Now, from a balanced reaction, we can see that 2 moles of the acid react with 1 mole of a base. Now, it means for the acid here, number of moles of an acid is this one. So we want to check if, what is that we are seeing here is that 2 moles of an acid will be reacting with 1 mole of a base. So what does that mean? It simply means to neutralize the acid, you have to divide this by 2. You have to divide 3,75 divided by 2 should give you, to know the number of moles of a base that you are going to need. So it will be the number of moles. Remember here, we know the number of moles of an acid is 3,75. So we want to check if this number of moles of an acid, 1,62, will be sufficient to neutralize the 3,75. So we might, what is that we do? We know that 2 of the acid will be reacting with 1 of this. So it means half of the acid will be required for the half number of moles of the acid will be required for the number of moles of a base, because they are in a ratio of 2:1. You need half of the acid for number of moles of a base. So you divide this by 2, which will give you 3,75 divided by 2, which is 1,875 mole of the base that will be required. So this will not be sufficient. So 120 gram of calcium hydroxide will not be sufficient to neutralize the acid, because you are requiring 1,875 mole, but you have 1,62. Right, let's carry on. Right, let me just make it a bit more legible and go through it again quickly. Right, remember we have calculated the number of moles of an acid. We have said that the number of moles of an acid is 3,75 mole of nitric acid. Now we need to calculate the number of moles of a base. So the number of moles is mass over molar mass. So in here it is mass, which is 120 divided by 74,1, which will be 1,62 mole. Now, from the balanced reaction, 2 mole of an acid react with 1 mole of a base. So it means for the number of moles of an acid, you will need half of it for the base in order to neutralize the acid. So you'll need half of the base. So what is half of the acid that is, half of the acid that is required is 3,75 divided by 2, which is 1,875. So now the ones of the base that is available is 1,62. So it means the base will not be sufficient, right? So let's carry on. Now, this will be the first page for the homework. I'll give you 1 minute to have it. All right, let's go to the next page. All right, you have to remember the definitions of concept discussed here, like, things like Arrhenius theory, Laurie Bronsted theory of an acid and a base. You also need to know what is an ampholyte, and then also be in a position to identify the conjugate base pairs. And you should be able to do calculation and example of the type of reaction. And what is important, you should be able to balance the reaction and use the previous DBE November question paper to revise, and any other material that can be useful. And then where you need help, please feel free to ask. This can be a useful link. And then I hope that we have gained something from this session. Let's meet tomorrow. We'll look at the homework and the redox reaction. And then contact me on masala.liburu@gmail.com, or on Twitter. You can get me at masaladl, or on Instagram, it's masala_silicon. Right. This is the end of the session. See you tomorrow then. Bye.